Good morning, everyone. Thanks for joining us for the second day of AI in Applications workshop. Today's session is on AI in net zero broadly. So with me, I have the pleasure of having the team from University of Hull. I know it's a bit early in the morning, but we'll get to a good start. We have a lot of exciting talks today. So I'd like to introduce the activities that we do at IIT Madras broadly in the team. I'm Professor Satyanarayanan Seshadri. I'm the faculty head for the Energy Consortium, which is a large umbrella initiative at IIT Madras looking at net zero transition. I also lead our School of Sustainability and recently been working on the topic of AI in net zero. In this talk, I'll briefly go over the introduction to our Energy Consortium and the various activity and come at it from a use case perspective. So where AI is being applied and put open certain open questions on what kind of challenges we see, and particularly with regards to the issues of ethics and responsibility. My core focus in terms of research is on energy systems design and typically measurements. So it involves multiple activities, including development of systems, development of system models, but also including development of digital twins, which is now becoming important. Primarily started out from the perspective of machine intelligence, but it's now becoming more and more important to understand a firm's performance and also relating to the safety of data that comes from many of these systems. We do now have a lot of connected systems. So how we really work, we started working on digital twins is primarily combining the physical asset and the digital twin and integrating it with a physics-based model. So we started this with the area of heat pumps and expanded it to the area of energy systems, particularly focused on buildings. And that's where the data collection aspect really comes in, because as we need to implement many of these, we start getting into a lot more energy consumption patterns, which could potentially be telling on the type of buildings and the type of activity that happens in those buildings, which certainly becomes a proxy to, in many cases, the output of, if it's an industrial setting, the output of that factory, or if it's a commercial setting, the operations of a particular building. So in the context of net zero, I just would like to highlight the activities of Energy Consortium. So we have, as an institute, pledged ourselves to contribute to about a gigaton of CO2 reduction through the technologies that we develop and the research that we translate. This is done through the Energy Consortium, and it is focused on many activities. And one of the challenges that you would notice is, as we model, I have just taken solar PV as a proxy here. Whereas you can imagine that any kind of transition, particularly when you say I want to do sustainable and I want to do energy, it is a multi-objective optimization. And in this case, there is not only a deterministic output, there is also a probabilistic output. And even in this case, there are questions that is very hard to answer as to what kind of prioritization, what kind of technology evolution, and how do you really source the data for many of these. It's available in literatures, it's available in published reports, but how do you really synthesize the data? And in the context of net zero, data availability itself becomes a very important element, as you don't have big data, you have small data with high variability. And how do you use the models that we have developed over many years for handling big data to apply to certain specific small models? And it also becomes important in the context of prioritization. This is the hierarchy of net zero that we use at IIT Madras, and also I will briefly introduce the Kotak IIT-M mission, where we do work with the MSMEs and the industries to collect data to help them in their net zero transition. And again, how do we enable such tools that we are building to help them reach their net zero goals? So broadly, as you see here, we mostly look with energy use, better energy utilization and energy efficiency, which really means it cannot be done without much of data that we gather. And of course, RE integration significantly relies on data integration as well. The remove carbon aspect, jo mostly talked about and funded, it actually comes way down in the value chain of net zero, because it's the most expensive and the least impact for the money that you will typically invest. So about the assessment cells itself, we do have a nationwide network of industrial assessments that we perform. In fact, one of the projects that we plan to work with Professor Jay at University of Hull is to compare how do we do industrial assessments here and with the UK and kind of mapping as what happens. But broadly, we work with many of these industries, collect data. Now, in the phase 3 of the project that we are about to launch next year, it's going to be a digital twinning of multiple of these entities, and we are already getting into issues of what identifiable information that you can gather and what could be a potential repercussions of knowing data, because energy, as you know, is a very good proxy to productivity. Even if everything else is suppressed, if you know the energy consumption, it's a very high likelihood that you can estimate how productive that firm has been, and you could actually detect a lot of evasions and other kinds of measures. So it becomes a sensitive issue as well. And the other topic that we generally have a challenge is the issue of critical technologies. I mean, it's just a broad highlight of so many of them that we are going after. And in this particular case, it is not so much about the data that becomes a problem. It is about the prioritization that becomes a problem, and how do we address this. And the approach that we are really taking in this particular case is to use the physics-informed machine learning type approaches, where we are trying to see what is already out there. And our objective at the Energy Consortium is accelerating net zero, which means there is an element of modeling and the data that we use from public sources and other published literature. So here the issue really comes from the ethical use of data that is published openly, but may have some issues with regards to copyrights, or may have some issues with regards to patentability and so on and so forth. Because as we see, data is published without much regard or due regards to copyrights as such, and that's the challenge that we are currently facing in there. So to quickly summarize, this is our consortium, Energy Consortium, that primarily works on all of these topics. It is set up as an industry, academia, government collaborative. We have 6 technology hubs, as you see here, in almost all the areas of energy transition. I lead the energy modeling and risk assessment group in addition to the energy efficiency activity. Primarily, objective is to develop tools, sandboxes, both experimental and modeling sandboxes to deliver on this. We are set up with 10 industry members of partners who have paid in a contribution upwards of about $1 million together as membership to be a part of this consortium, which again helps evolve strategies together. The recent addition to this is Saudi Aramco, who is the 11th member, and we have Caterpillar, who is joining as the 12th member. And it's a carefully constructed mix of industries from generation, consumption, utilization, and OEMs as well, so that we know how this transition is happening. And one challenge we repeatedly face, maybe I'll take about 5 more minutes to introduce this and the context of AI that we are applying, is how do we determine what to fund, what not to fund, and how do we determine what policies and what incentives, and how do we really determine action is a challenge. Because if you really look at net zero, you can look at it in this kind of a matrix where you have the adaptation and you have the mitigation. Adaptation is assuming it will happen, and it is likely that more and more activities are focused on adaptation, because we do see the events that's unfolding. I just joke, whenever we run an energy conference here, this is 4th time in a year, we always invite the weather. It's always been either a cyclone or some kind of flooding every single year. The first time it was COVID, but every other year it has been some kind of a climate event that happens along with our conference. So I think adaptation is an important area, but we also have to figure out mitigation. And mitigation, both short-term and long-term. Short-terms are easy to handle because we have a reasonably deterministic output on short-term, but long-term is still evolving, and that's the reason why it is almost always underfunded. So if you really look at the promised requirements of money for transition, which runs into trillions of dollars, and actual deployed commitment, it's not even $100 billion. This has been since COP25. So the reason is this. The reason is you don't know where to deploy, and the best course of action when you don't know what to do is keep quiet. So that's the challenge that we are trying to address through the climate action tool and through integrated modeling. So how are we really looking at it? Most of the time you have a top-down data which says, here is your global consumption, your country's import-export, and then now we figure out what happens. But what we are doing is a bottom-up assessment where we say, can I look at a empirical parameterized optimization framework, and how do we do that? I can always build from a component, an aggregation of component is a factory, aggregation of factories is an industry, and aggregation of industries is a cross sector. And multiple sectors form a national output. So with this framework, we kind of developed this tool and applied it to a certain problem statement. We said, hey, can I do integrated assessment for utilization of multiple fuels for multiple sectors? In this case, cement, steel, and power, because they compete for resources, particularly energy resources. So what's the output? If I were to look at how do I suggest a mix of energy systems for different entities, this is the first level output that comes here. Now, in this particular case, where we are trying to apply AI-based tools particularly is to validate these things. Validate based on learned experience, published literature, published scientific reports, and also other kinds of documents so that we can build a data set. In almost all of net zero applications of AI, the starting bottleneck is availability of data. All kinds of data, not just machine data, but all kinds of data. So how do we really solve that problem? Because otherwise, we would talk about all of these problems, which could probably solve maybe using a pen and paper. So that's a challenge that we are really looking at. In this case, we did develop the model, and some cases we did digitize and make data available. And the question that we are asking is, what is the impact of transition? The answer that we want to have is, if you make cement green cement, how much more expensive? Our answer here is that it's going to be about 120% more expensive with 75% reduction in CO2 estimates. Now, this is deterministic. It is unlikely to be what you realize. The tools that we want to build to say, what is your confidence interval on this, and how do you have data backing on these kinds of estimates? Similarly, on steel, we see that 55% increase in the cost, and in power, we see about 5%, which is reasonable because renewable is already there. So these are questions that you can ask proactively, future looking. The last last thing that I want to share is how do you look at it post facto? If some decisions have been made in history, can you go back and look at it from data to say it could have been better? Because most often we have the right intent. What is missing is the quantum of action is too small. In terms of saying, if I want to take action right now, you give some incentives, you give some sticks or penalties, but it's too small. The example here is the perform, achieve, trade mechanism that was driven by India's Bureau of Energy Efficiency to really deliver on energy efficiency targets for heavy consumers. And what we found out is over a period of 7 cycles, the target setting was too easy and too easy to achieve. They could have actually jumped a bunch of cycles and actually gone towards a very stringent target right in the beginning. But you always have this whole lobby of, will it be met or not met? It's too expensive and so on. And we used the CAT tool to go back and estimate saying, is the target strong? And we did find out that the whole objective of this perform, achieve, and trade part of it is difficult to achieve. So some companies will achieve, some will not. So there is going to be a market that will be found for trading. And the history tells us that all the initial 7 cycles, or 6 of the 7 cycles, there was not much trading. It was everybody was able to meet the targets. And why was it? It's because the targets and incentives are too weak. Could we have predicted it? We could have predicted it if we had an integrative assessment framework. And that's the objective. And now this whole mechanism is transitioned to a carbon market. Now the question again comes back to say, what is the price of carbon? How will it be attractive? And what kind of incentives will drive the adoption? So overall, I think there is a requirement for combining many of these activities together and see how do we come up with solutions that is meaningful and backed up by proper data. Of course, the whole activities that we do in terms of our MSME audits, we also look at collection of a lot of data. So here, there are couple of issues that come, and the 2 things that really comes, this rest of it is usual, but the 2 things that generally comes is efficiency and accuracy and data security. Efficiency and accuracy, because if you are going to make decisions based on the models and the tools that you build, the efficiency and accuracy of it is important, and the security of data, particularly when it is sensitive data or competitive data. So I'll just leave you with some of open questions. I think you will hear from a lot of people today about these, but the core set of open questions are on data ownership, particularly from IoT devices that are used for model building, without which there is no control action, without which there is no optimization. But then when you build an optimization model, particularly say building energy models and so on, I will be using multiple models from multiple buildings to create that framework. So how do we ascribe ownership? The second thing is really about denial of benefits. As I said, when I collect data, I expose the company. It is towards driving optimization. It is towards driving energy efficiency. It is towards driving net zero goals. It is a collective benefit. But sometimes in the process, individuals get penalized, companies that don't perform, companies that have been hiding income or whatever, that gets exposed fairly easily. And the last question is cost of net zero application of AI. AI itself is not cheap from an energy perspective. It is energy intensive. Now, does it even make sense? Who does the Pareto of should I use AI? Or the last question of my bullet is, do we even need AI in these cases? Does net zero need AI? Or are we really only talking about data security when we talk about responsibility and ethics and so on? So this is still an open question. We really haven't found a convincing answer that I need to apply AI, because all of what I talked before could have been done with traditional analysis, regression modeling, and so on and so forth. What is AI bringing to the table here is a question we need to answer. I'm coming at it primarily from a domain perspective. I know that I'm in an AI conference, but we just want to figure out how to use it. Thank you very much, and enjoy the rest of the day. I think I have my colleague, Professor Nishikant Mishra from Hull University.
Good morning, everyone, and thank you, Satya. Now, let me introduce myself. Nishikant Mishra. I'm professor in logistics and supply chain at Hull University. And as far as my background is concerned, my first degree is in manufacturing engineering, then PhD in computer science in healthcare project. Now I'm based in business school. And when me and Dhaval was talking about this one, then I was thinking I am the best person because I know the healthcare, I know the logistics and transportation, net zero. And yesterday you have already seen a lot of talk related to healthcare. Now we are going to talk about the net zero and manufacturing and logistic related activity. Let me give you some background of the Logistic Institute. I'm based in University of Hull. We have a dedicated Logistic Institute there, funded in 2007 funded by the EU. And you can see that Logistic Institute, Hull Logistic Institute is the first dedicated center related to logistic related activity. And the main objective of this center is to think about how we can develop a sustainable freight transportation. And we are working closely with industry, we are working closely with policymaker, and we are also a lot of program to generate a future researcher. Now today I'm going to give you the flavor of some of the project, but before that I'm going to talk you some of the program that we run. We have undergraduate logistics and supply chain. We have a postgraduate logistics and supply chain, and we have both face-to-face and an online program. We have also some interdisciplinary course related to engineering management, artificial AI and data science type of thing. We have also the PhD program dedicated to logistics and supply chain. Now I'm going to give you some of the project we are doing related to net zero and logistics. First project we started, if you are familiar with the UK, in 90% goods, they are coming from outside. UK does not produce anything nowadays. They are bringing all the stuff from outside. And if you are familiar with the UK, majority of stuff is coming at the Dover airport, located in the south. And more than 60% consumption is on the north. And the product travels via road. That create a lot of traffic congestion and carbon emission. Simultaneously, there is one port that is located in the north, near to the Humber, where Hull University is located. Then we had a lot of discussion with the different government body and also the lot of retailer. We mentioned why we can't bring the product from outside to the Humber airport. They are saying the infrastructure is not sufficient. Then we had talked with a lot of retailer. Then policymaker, they are saying, show me the demand, I will put the infrastructure. This looked like the chicken and egg problem, who will start first? Then we started this project, and then in this project, our main objective is to unlock the potential to like we are collecting all the data that how much the product is moving from the south to north, and then we are also talking with the different retailer how they can consolidate the demand so that they can show that there is enough demand that they can bring into the north port near to the Humber, so that the government they can put the infrastructure. That we identify the most effective in the route for cargo travel through UK port. In this project, as I already mentioned, that we are exploring if they can bring the product to the Humber airport, how much the carbon they can save, how much the like traffic congestion they can. And here we are using the simulation and AI to demonstrate it. While working on that project, we realized that this is not sufficient. If you are familiar with the port, always there is a traffic congestion near to the port. Always when there you then we started discussing with the different transport provider and the policy maker. We realized that where is the problem? Problem is that there is a lack of real-time information flow between the ship and the port. That create a lot of traffic congestion near to the port. You can see that in 2015, because of the traffic congestion near to the port, that costed 250 million. This is not a small amount of money. And then we started doing the real-time simulation so that we can develop a real-time information flow between the port and the land. While completing the first and second project, we realized that now we have in a position to help UK for net zero. Then we realized that, okay, this is still not sufficient. Then while working on that two projects, that is Loft and Capital, as I described, we realized that there is another potential inland transport system. If you can see in UK, there are a lot of small canal. There are small boat and ship they can use to reduce the traffic congestion. Then we started exploring how they can use this water inland transportation system. So that if I can combine all the three projects, Loft is how they can minimize they can bring a lot of product in the north, and the real-time information flow between the ship and the road, and the water inland transportation system. Maybe that is going to solve the transportation-related problem. But we realized that this is not sufficient. We need to somehow, if we are only using the road, road is usually emit a lot of carbon. Simultaneously, we can use the rail. Then we started talking with the rail provider. And look like UK is a developed country. When I started talking with a lot of rail provider, we are thinking, okay, they have all the data and everything is available. We can easily connect with the road and the rail. In my first conversation with the rail provider, we realized that they are still doing a lot of manual process. There's no digitalization of the whole rail infrastructure. Then we mentioned our team, welcome to the research. And then first time we develop a digital map of whole UK system, because we are thinking in order to combine road and rail simultaneously, we need a digital system. That's why first time we develop a UK rail digital system. As soon as we develop that system, thereafter, we realize how we can minimize the carbon related to rail. Rail system is more complex than road. When the rail travel on the track, it is hard to measure how much carbon they emit. Previously, when I started that project, I was thinking it is easy. But when they move in different slope, different turn, and the different driver changing their behavior, that emit different type of carbon. And then we have existing calculator was very generic to calculate the carbon. Then we develop more like a specialized calculator related to rail to calculate the carbon. And then we have also, using our digital map, we are also helping rail provider to predict the delay. If they can predict the delay more accurately, they can easily manage the infrastructure and they can minimize the carbon emission. You can see that we are slowly progressing. We started from the road, we moved to rail. Now we are also thinking about, is it possibility to connect the sea, road, rail, and air so that we can develop more holistic system. Now we are trying to do some project related to air. Now I'm also going to give you some of the other projects we are doing. If, as already mentioned, in UK, 90% product is coming from outside, including the perishable product. Think about the grapes, fruit that we eat in UK. It is coming from South Africa in a big container. When it moved from the South Africa to UK, temperature change more frequently. That create a lot of waste. Then we had a lot of conversation with one big retailer in UK known as Morrison. When the big container they are coming from the land to sea and everything, you can see temperature fluctuate a lot, especially in big container, in different layer. If the temperature fluctuate a lot, that create a lot of waste, food waste, because the grapes is very sensitive to temperature. Then we develop a good sensor so that we can manage, and we are using AI so that that can automatically manage the temperature and automatically control the temperature. That can help big retailer to minimize the waste. Now I'm also going to give you another project that recently we finished that is related to India. This is a very big project, 7 million project related to second green revolution in India. As you know, in first green revolution in India, their main objective was to increase the productivity. But now, as soon as you increase the productivity, next thing is how to save the natural resource, especially water. And in this project, that was a 7 million project led by the Cambridge University and the Hull University, and also a lot of different partners in India. In this project, I was leading one work package. In that work package, we did a simulation so that we did how the crop rotation. If you rotate the crops, you can manage the water more efficiently during the crop production. And in this project, we work closely with the Punjab government. As you know, in Punjab, there is a lot of rice yield. And through this project, we are providing a lot of policy recommendation. Hopefully, that is going to help India to save the natural water resource. There is another project that we did related to how we can use blockchain to minimize the carbon emission in the food supply chain. You can see that when I'm talking with a lot of food supply chain stakeholder, they can manage and minimize the carbon at their end. Take example, when I'm talking with the farmer, they can say, yes, they can manage, they can minimize. When I'm talking with the logistic provider, but there is a need for the integration. We need a system thinking approach. If we will not combine, because the carbon emission at one end is related to other. And thereafter, we had a lot of discussion with the big retailer. We have completed one project around 2 million with Sainsbury. We helped them to minimize the waste in the food supply chain. And then through that project, we have also generated the idea how we can use the cloud computing technology so that a big retailer, they have idea how much carbon each kg of the product they have emitted, how the different provider they are doing so that they can provide help them, they can minimize the carbon emission. Here we extended that project. Now we have also used the blockchain technology. I can give you why this project is important. As I already mentioned, in UK, a lot of product is coming from outside. Suppose there is a big retailer, Tesco, Sainsbury, they are really big retailer, like we have a Reliance Food here in India. If they want to, and suppose in UK, the food is coming from Africa, they want to help the African farmer to minimize the carbon emission, hard. But through this blockchain technology, they can easily guide them, they can easily track, they can easily monitor. and that can help them to effectively manage the carbon emission. We are also doing one project that I have not added here. I'm doing with the Dhaval related to the, Dhaval is also involved. We are working closely with the one company where we are trying to increase the life of the laptop. If you can see, the life of the laptop is usually 3 years. After 3 years, they discard, especially in developed country like in UK, where the maintenance service is not that good. After 3 years, they usually discard the laptop. But through the proper maintenance, you can easily increase from 3 years to 9 years. We are developing a decision support system. That decision support system will guide individual how they can maintain the laptop, and so that they can increase the life of the laptop from 3 years to 9 years, and that can lead to a lot of saving of carbon emission, because when they produce one laptop that emit a lot of carbon. And now you can see Satya was talking about a lot of things related to manufacturing, how they can save the carbon emission related to manufacturing sector. In University of Hull, we are doing a lot of research related to logistic and other activity, and I can see there's a lot of potential. If we both can work together, that can help us to save our earth.